for this section of function and models. The goal is pretty much to recognize and understand the various business and economic terms like terminology, the terms that you're going to see along the semester, and use it as a function name. For example, we use the capital C as a function of the cost or the cost function. Okay. And then when you replace x with a 0, that means the fixed cost. The variable cost would be the difference of the function cx and the fixed cost. And the rx, the capital R, that's from the revenue, that represents the function for the revenue. The lowercase p represent the price or the price function, and sometimes refer to the demand function, the supply function. The capital P, so make sure when you write the work, when you submit for me after the exam, the lowercase p for the price, the uppercase P for the profit, they do not represent the same thing. And the profit is the difference between the revenue and the cost, or the capital P is the difference of the capital R and capital C function. Okay, revenue minus cost. Every semester, I got a student said the profit is C minus R. How would you think about it? I mean, the cost minus revenue to give you profit. I don't think you should stay with the business major, you know. Anyway, revenue minus cost, that give you the profit. Break-even point where the revenue equals cost function or the profit equals 0. So this part, we're gonna have to solve the algebraic equation. And when you see equal sign, that means you have the equation and the variable x, that what you are looking for as the final answer. Okay, supply function, as I mentioned earlier, the lowercase p can represent either supply function or demand function. To be more specific, for the supply, they use the uppercase S as a notation for the supply function, the uppercase D as lowercase p as well to represent a demand function. Equilibrium point, the lowercase p subscript E from equilibrium point, that means demand equals supply. Okay, S equals D. And when you set up this like what you see, the S equals D, that means we are going to look for the X that represent the quantity that demand equals supply. And then after we got the X as the item produced, and then you use the X to find the value P. How do you find the value P? You can use the X from solving the S equals D, plug it in either D or either S here. Just question, Min? Do you have question, Min?
Huh? Oh no, I do not.
Oh, okay. I thought like you were going to ask question.
Oh, did I make any voice? Oh.
Somehow like the screen like moved to your window, and I thought like you were saying that I
Oh
could
yeah.
catch.
Oh.
That's all good. All good. Yeah. So the order pair, you have done the order pair of the numbers when you took math courses, but now for some applications for this course, going to be order pair of the X as the item produced and the P as the price or the demand value or the supply value, put them together. And since P is a function of the X, so you have to know the input X and put in the function to get the output. Okay. The revenue in terms of unit price, the revenue is the item produced multiply or the item sold multiplied by the demand function, or the X multiplied by the lowercase p. Some problems you're gonna set up or find the function R or the revenue function using the product of the X or the item sold and the P as the price function or the demand function. Okay, so right now it's just the general notation that you're gonna see on and off. Okay, for the first example, let me manage my screen real quick. We're gonna touch like different models, different examples that use the function to go through the problem. Like for the first one here, when you have the problem, most problems you see in the course gonna be long problem. Basically, you are dealing with a word problem. Number one, you have to read the problem, read it carefully, and identify what you know, what you don't know. And some problems, like this one, you have sub problems. They give you information, and you have to write the cost function, you have to write the revenue function, you have to write the profit function, and then you're gonna find the break-even point. So multiple parts in the problem. That means whatever you have, use information to get to the answer. Okay, like number one, a soft drink company has fixed cost of $4,000 per day. The variable cost, so you see the two different things for this problem. You have the fixed cost and the variable cost. And then another part is that each case sells for $5.25. So for the first part, they ask for the cost function. And if you you haven't done math in a long time, but for the problem, just think about the common sense together with the content in math to find the cost function. As I highlighted the key terms here, the fixed cost and variable cost. So basically the cost function that represent the total cost, okay, the total cost. If you look for the total cost, the general notation is CX. And the cost, since they are two different things, the fixed cost and the variable cost, the total gonna come from the sum of the fixed cost and the variable cost. Okay. All right. So from information that we have, what is the fixed cost? Whatever that the number of the cases sell for that day, you're gonna have the fixed cost for 4,000. Okay. And then the variable cost is gonna be $2.75 per case. So $2.75 per case. How many cases you sell for a day? You don't know, right? So that means
Yeah.
the unknown, I'm gonna put a note here. The unknown would be X, which means the number of the cases that sold for the day. Okay, so that means the variable cost is going to be $2.75 multiplied by X. Okay, so for part A, the answer is going to be C of X, as C as a function, depends on the X or the number of the cases sold, equals 4,000 added by 2.75 multiplied by X, and I box it. So this is the answer for part A. Okay, so part A is done. And then the next one, part B, revenue function. The revenue function, the capital R, Rx, depends on the number, the X. X is the cases sold per day. The another part of information that you are provided would be the each case sold for $5.25. So that means how many cases sold? X cases, right? And how much per case? $5.25. So now you get the function which is called the revenue function for part B. So far, so good?
Hmm.
Okay, very good. And then the next part, part C, the profit function. Key term profit. Profit is a capital P. The profit is from the revenue minus the cost. Okay, the CX. So let me. The revenue minus the cost, and the revenue from part B is 5.25x subtracted by, you see the CX or the cost function, they are two terms. To save your life, put the parentheses. Why I call save your life? Because if you omit the parentheses, it's possible for you to misuse the operation because you subtract both numbers at the same time. So to do the math, you take away the grouping symbol. That means you distribute the negative side to both numbers. So negative side there, right? So subtracted by 2.75x. And after that, you just clean up or simplify the numbers. Look for like terms. I keep saying the key terms that you have heard like many times when you took algebra courses. Okay, key term, light term. Light term means you have the same variable, but you have different coefficient. What you have to do, you just add or subtract the numbers. Like for this case, you're gonna do, I'm gonna write them next to each other. 5.25x minus 2.75x, and then subtracted by 4,000. And I consider these two as the two light terms. What you have to do, like you have one apple and two apple. How many apple in total? You just add or subtract the numbers, right? So 5.25 minus 2.75, it comes out to be 2.5x and then minus 4,000. And this is the function for the profit. Sorry for the room that I did not provide enough. So this is a profit for part C. Okay?
Mm-hmm.
Now we got the cost, we have the revenue, we have the profit. And the last part, we're gonna find the break-even point. For the break-even point, that means the profit is zero or no profit. Mhm. So the profit is zero, or the PX, the capital P of X equals zero, the break-even point, or you can say the revenue equals the cost. So either way, depends on how you set up the problem, but they all have the same meaning, okay? To find the break-even point, or to find the X, or the number produced, or the number of the cases sold when the cost equals the revenue, you either use the profit function equals zero, or equate the revenue and the cost together. Up to you, it doesn't matter. Since this problem, we already found the profit function. I'm gonna take the px, or the profit function from part C. Okay, I'm gonna set up by using the profit equals zero. So the profit is 2.5x minus 4,000 equals zero. That's the setup for part D that I chose. And then what I have to do, I'm gonna solve for x. Okay, I'm gonna solve for x. And to solve for x, as you did with the algebraic procedure, to add 4,000 both sides of the equal sign, right? And then you would get 2.5x equals 4,000. And then what you have to do, you're gonna have x alone. So then you divide both sides by 2.5. What do we have? The x equals 4,000 divided by 2.5. If you have the calculator handy, you can help me to find the number. Or put in the chat, or you can turn on the microphone and let me know. What do we get for 4,000 divided by 2.5?
1,600.
1,600. Thank you. Yep, so this is the break-even point that the revenue equals the cost based on the information provided in this problem.